Hi everyone, we'll talk LeetCode 22, general parentheses today. It's a very typical backtracking problem. Also, you can use iterative solution to solve it. But personally, I pretty like this problem since it's LeetCode 22 and it's very good for beginners to let beginners to practice backtracking stuff in algorithm. So let's take a look at this problem. We are given n pairs of parentheses, so we're asked to write a function to generate all combinations of well-formed parentheses. So what is well-formed? Let's take a look. It means for every closing bracket, we must have an open bracket before it. For example, if your string starts with a closing bracket, then it's not a well-formed parenthesis since it does not have a corresponding open bracket. Okay, so let's say the constraints. The constraints n is greater or equal than 1, but is less or equal than 8. So n is pretty small. If we are using backtracking, we will not get here e for this problem since n is such a small number. Okay, let's implement it. So this is the code framework. For the main function, we declare the parentheses. It's a vector string, is our answer. Then we use DFS function to generate it and finally return our answer. Okay, for the DFS function, it accepts 4 parameters. The first one is a string s. It is the current string, like we are constructing. And the second parameter is how many open brackets we have, like we can use. So at first, we have n open bracket. And same for this parameter, we have n closing bracket. And this is our answer parentheses, and we pass by reference here. So we can update it in this function. Okay, first, it's a corner case. For a non-well-formed string, we know we use the more closing bracket. So which means we have less closing bracket available. So if close is smaller than open, we just cut this branch. Since in this case, we have more closing brackets than open bracket. Okay, if open is 0, which means we use up all the open bracket, which we left is closing bracket. Then we can just use all the closing bracket and append it to my current string. Then my current string is a well-formed combination, and I can just push back this string into my answer. Okay, otherwise we have 2 branches. Like we can pick the open bracket, or I can pick the closing bracket. So there are 2 branches here. So one branch can generate 2 sub-branches, 2 children branches. Okay, if we're using open bracket, then the open will be smaller since we use 1. Otherwise, for this branch, we use a closing bracket. So close is close minus 1. Okay, so for this problem, this is a clean solution, a clean backtracking solution. So what's the time complexity for this solution? I cannot get a very accurate time complexity, but we know there are n open bracket and n closing bracket. So there are 2 n bracket in total. And we know each time we can pick closing and we can pick open bracket. So every branch has 2 children branch, and the depth of the DFS can be at most 2n. So in worst case, the time complexity is 2n, but we know there are too many invalid branches we kills pretty early. So it's not trivial to get the accurate time complexity. What I can say is at most, like at worst, the time complexity is 2n. Yeah, okay, that's a problem. Thanks for watching.